Okay, so today we will continue the indexes topic. In the previous lesson, we learned about the clustered and non-clustered indexes. And today we will move on to unique indexes. Okay, then difference between a unique index and a unique constraint. Okay. Before that, I want to remind what is unique constraint to begin with. So if you remember, the unique constraint is forced on one or multiple columns to enforce uniqueness across those specified columns. So now keep this in mind, and then we'll continue with the unique index now. Okay, so unique index. It is used to enforce uniqueness of key values in the index. It is very similar to unique key constraint, but there are differences. So the definition says it is used to enforce uniqueness of key values in the index. And there's a note: by default, primary key constraint creates a unique clustered index. So basically, the main types of indexes are actually clustered and non-clustered indexes. Okay, they can be compared to primary key and a unique key constraints. That's why primary key constraint by default will create a clustered index that is also unique, because the primary key itself, not the index but the actual primary key, it enforces uniqueness across that column, right? If you remember, and it does not allow any nulls. So that being in mind, when you create the primary key, it actually creates a clustered index, which is also unique. And clustered index, it will actually restore or order the data in the table physically. Because without the index, the data in the table is usually a heap. Heap means it's mixed and it's in the order as it was inserted into the table. Okay? So once you create the primary key constraint, that will apply the clustered index, also a unique clustered index, and that in its turn will organize the data in that table in particular order. Like if the clustered index was created on this ID column in ascending order, so now this index forces the data in the table or the rows in that table to be physically ordered in ascending order by that ID column. Okay. So uniqueness, now the next thing is, uniqueness is a property of an index. Both clustered and non-clustered indexes can be unique. Okay? So one more thing is, like, when we're saying unique index, it is not actually a new type of index, okay? It is just a property of an index. That's why if you look at this create index statement, it's not saying create unique index. It's saying create unique non-clustered index. Okay, so the type is actually non-clustered. Okay, the type of the index is non-clustered. So unique is just property of that index. Okay,
can be clustered and non-clustered.
Yes. So basically, you can imagine it as there's only two types of indexes. one is clustered and one is non-clustered.
Yeah.
And then they both can be unique or non-unique. So it can be unique non-clustered index or unique clustered index.
Mm-hmm.
Okay? So the actual types of indexes are clustered and non-clustered.
Yeah.
Okay? So that's why when you take a look at this statement, it says create unique non-clustered index. It could also say create non-clustered index without the unique part.
Yeah.
But you cannot say create unique index.
Yeah.
Okay? It is just a property of index, whether it be non-clustered or clustered. Okay? So when you want to create the unique clustered or non-clustered index, this is the syntax. You basically just put the word unique right after the word create.
Yeah.
Okay? And the rest is the same. You give the index name and on whichever table and whichever column or columns on that table.
Mm-hmm.
And then the best practices or naming convention for the unique index is UIX.
Yeah.
If it was just an index, it would be just IX. If it's a unique index, it's usually UIX. This is not that you have to do it, like you could name an index without this part. The best practices is that you should add this as a suffix so that people, when they see your indexes, they should know that it's an index.
Yeah.
Shouldn't be confused.
Mm-hmm.
And now let's see the difference between unique constraint and unique index. So if unique constraint also enforces uniqueness, and then the unique index also enforces uniqueness, so then there must be some differences, right?
Yeah.
Well, basically, there are no major differences between a unique constraint and a unique index. Okay? It's almost the same thing. But in fact, when you add a unique constraint, a unique index gets created behind the scenes. So you can actually say unique index is like the thing that actually moves the unique constraint. Unique index is the power that's behind the unique constraint. Okay.
Mm-hmm.
And now, unique index again. When should you be creating a unique constraint over a unique index? Okay.
Mm-hmm.
If there is no major differences, if these two things are almost the same, which one should you choose and when? Should you create a unique constraint or a unique index? Okay.
Yeah.
So as it says here, to make our intentions clear, create a unique constraint when data integrity is the objective.
Mm-hmm.
Okay. So what is the data integrity? Data integrity means basically data integrity is the part of data being clean.
Yeah.
Okay. You shouldn't have multiple same things in one table, right?
Yeah.
So if your objective is just to store one value for each item in your table, like if you want it to be distinct, then use the unique key constraint.
Yeah.
Okay.
Mm-hmm.
So, and this makes the objective of the index very clear. In either cases, data is validated in the same manner, and the query optimizer doesn't differentiate between a unique index created by a unique constraint or manually created. Basically, when you create the unique constraint, the unique index gets created automatically, so it doesn't really matter. So if you use the unique constraint, you will have the unique index anyway.
Yeah.
So then useful points to remember. By default, a primary key constraint creates a unique clustered index, where a unique constraint creates a unique non-clustered index. Okay? And these defaults can be changed if you wish to. So now we need to separate these four things. So we have constraints. The main two differences, like we have constraints,
Yeah.
and we have indexes, right?
Yeah.
If you eliminate the fact that index actually speeds up the scanning process, they are the same thing. Okay? Like, for example, primary key also enforces uniqueness across that column, and it also actually physically orders the data in the table. A unique clustered index does the same thing.
Yeah.
And then unique constraint also enforces uniqueness across one or multiple columns. And it also, if it's it creates a unique non-clustered index. In that way, they are the same things. Indexes, apart from that, they also speed up the process.
Yeah.
Okay. So basically, say also the primary key, you can have only one primary key on a table. And it's just like the primary key, the unique clustered index, also you can have only one on a table.
Yeah.
And a unique constraint, you can have as many unique constraints as you want. And also, well, basically not as many, but like 16. And also non-clustered index, the same.
Yeah.
Okay. So only difference then becomes the speeding process. Indexes actually speed the scanning process with the help of that tree concept.
Yeah.
Okay. Second thing is a unique constraint or a unique index cannot be created on an existing table if the table contains duplicate values in the key columns. So, like, imagine now we have an existing table.
Yeah.
And that table already has duplicate values. Okay? Therefore, you cannot create a unique index or unique constraint on that column of that table because there is already duplicate values in that column. That contradicts with the basics of the unique index or unique constraint, because the whole purpose of this unique constraint or unique index is to enforce uniqueness.
Yeah.
If you already have duplicate data, then you cannot apply unique index or unique constraint because it doesn't make sense. And now imagine if you could create a unique index or unique constraint where there was duplicate data, then it wouldn't be unique, right?
Yeah.
That's why the SQL Server doesn't let you create unique index or the unique constraint on a table that already has duplicate data. Okay? We'll see that in action in a minute. So obviously, to solve this, remove the key columns from the index definition and delete or update the duplicate values. If you remember the previous time when we tried to add unique clustered index on a table, we have to remove the duplicates first. Otherwise, it wouldn't let us do that. Okay? So let's see all of this in action. First thing now, let's see. We have this salesman table, right? And we have this duplicate values on this ID column. That's 5011 and again 5011, right? Now, I believe we also had some unique constraint across this ID and name columns. Let's see if we have that. We'll have to delete that constraint. Okay. Yeah, so we have two indexes. Let's delete both of them. Okay. And also, I think we had constraints. Okay, we don't have them. Now, first thing, let us try to create a unique on ID column. Okay. We have duplicate value on this ID column, these two values, right? Ideally, it shouldn't let us create that unique index because there's already a duplicate value. Okay?
Yeah.
Now let's try that. Let's say create unique clustered index will be unique index ID on salesman ID column. Okay? And let's say order will be ascending. And let's try. You see? We'll get this error when we try to create especially a unique index on an existing table that already has duplicate data. This will say the create unique index statement terminated. It says it stopped because a duplicate was found for the object name GBO salesman and the index name this. And then it will also show you which exactly is the duplicate key. You see? Basically saying this value 5011 is duplicate in this table, and that is true because we have duplicate. So to solve this, you either need to update this so that it will not be duplicate. Okay, you need to change one of these 5011s to something else, or you could also add another column so that it will not be duplicate. But adding another column might not meet the requirements of the business. Okay? So now what we can do is we can update the table. Do you remember how to write the update statement?
Yeah, update set to.
Okay, now you need to tell me what should I write. I want to update this 5011 to let's say 5013.
We update
And
ID from.
so now now I can create the index. Okay, you see? Now the index is created. Since it's a clustered index, ideally it should reorganize the data in ascending order. You see? 10, 11, 12, 13.
I have one question regarding like this.
Okay.
Can we use at the same time? We can use the order by clause too, yeah. So
Order by clause in where?
so like if we need to order it by, we also can use and order by. So function will be the same.
Yes, but now you try to tell me first what is the difference. If not, then I will tell you the difference. So, okay, now let's try this thing. I'll remove this and just put star there. So now, actually, let me first remove this also. We'll start from scratch. Drop index this on salesman ID. Well, actually, we don't have to, I guess, specify the column, but yeah. Okay, now we don't have the index, but since it was already organized, let me insert one more value here. Okay, before we move on, because there is a reason I will tell you. So the second result is coming from the select all from the salesman table as it is. So this means select everything from this table as it is, like whatever order that is in the table. This one is bringing the selecting it and ordering it by ID ascending, right? So therefore we see this difference. So this one is the ordered, and this is the actual order of the data in the table as it was inserted, right?
Yeah.
You see, so order by clause, it will just retrieve the data and then order the data, okay? It will not actually reorganize the data, okay? And now let's create this index again, okay? Created the index. Now do select this 2 again. If you look at this one, now this is the ordered table, right? With the ordered by clause. 0, 1, 2, 3, and so on, 13, 15, 16. And if you look at this one, now this is the actual table. Okay. It's also ordered in the ascending order of the ID. 0, 1, 2, 3, and 15, and 16. Okay, so basically after we created this index, it ordered or reorganized the table, like the physical table, like table, the data in the actual table got organized. You see, if I do a select star now, it's not a heap anymore. See? It's starting from 0, 1, 2, 3, 4, and so on. It's actually ordered.
Yeah.
It's not a heap anymore. And only thing I'm doing is I'm only doing a select star. I'm not even doing any order by or anything.
Yeah.
Okay? So that is the difference. The difference is then, if you have a clustered index, and that is ordered in ascending or descending order, doesn't matter, it will take the actual data in the table, reorder or reorganize the data in the actual table, the physical table.
Yeah.
Okay? So basically, this is the actual order of the data in the table now, since we're only doing a select star without any order by clause, right?
Yeah.
But the order by clause, what it does is, it only shows you the data in an ordered manner.
Yeah.
It doesn't actually order the physical data. Okay? So the data is, it can be like a heap. The table can be a heap, like not organized, and it will stay the same even though you use the order by clause. Order by clause will only show you the data in an ordered manner, but it will not actually order the data physically.
Yeah.
So the data will still stay as it is, as it's inserted. Like if it's mixed, it's still mixed. It's only showing you it as ordered. But when you create a unique clustered index, it doesn't have to be unique, but like clustered index, it actually orders the physical data in the table.
Yeah.
Does that make sense?
physical data, yeah, like all the column.
Yeah, the actual data as it was inserted.
Yeah, yeah.
Okay.
Mm-hmm.
So the table will be actually organized.
Yeah,
The data in your table is actually organized in one order.
yeah, yeah.
Order by clause, it will just show you as it as organized, but it's actually not organized. Okay. You can, I guess you can imagine it like let's say basically order by clause is just image. Okay.
Mm-hmm.
It's not the actual real data. It's just the image like it shows you. It will take the heap and it will just order it and show you, but it's not actually ordering the actual data.
Yeah.
Okay. But the index will actually order the data.
Yeah.
And why? Why don't we just use the order by then? Thing is, because the index has to speed up the process, right?
Yeah.
Now imagine if I have, well, since I have the index now and the data is actually ordered,
Mm-hmm. Mm-hmm.
whenever I do a search on this, say for example, any of this, say, let's say where ID equals to 5009, right? So when I do this, where 5009, now the actual data is organized, right? What's happening behind the scenes now is, since the data, the SQL Server knows that the ID column is ordered in an ascending row,
Mm-hmm.
and we're looking for 5009,
Yeah.
since it's unique,
Mm-hmm.
now what happens is SQL Server will know what is the number in the first position and what is the number in the last position.
Yeah.
So now we have 16 rows, and it's ordered in an ascending order, and it's looking for 5009. So now it will know that 5009 is somewhere after the middle.
Yeah.
Right? So it will just jump to the middle.
Yeah.
Okay? So it will know that it's after this 00, since it's in an ascending order, before this, and then after this, and before this. So it will just jump right here.
Yeah.
You see? That's why we have the estimated execution plan and the actual execution plan. So basically SQL Server, before executing anything, create an execution plan. It will calculate rows in that table, and if there is an index or not, and if the index is in an ascending order or descending order,
Mm-hmm.
and then after that, it will just take action and jump into right where the result is based on the calculations. Okay. Now imagine if this was not ordered and it was like mixed up. 5009 is here, but 16 is here, 3 is after 5009, then it wouldn't make any sense, right? SQL Server would have no idea how to retrieve this row only because there is no logic. It's all mixed up. That's why the cluster index will actually reorganize the table itself so that anytime when you look for something, it can calculate the estimated position for that row.
Yeah.
Okay?
Mm-hmm.
In case of order by doesn't actually reorder the data, so it doesn't help. It's only for showing purposes. It only will show you the data in an organized manner. But it will not actually organize the data, and therefore, it doesn't help speed up the process.
Mm-hmm.
Since your actual data is not organized, SQL Server will not know where to look, what logic to follow.
Yeah.
Like, for example, if I tell you, let's say we have 100 people lined up. And you are number 1, and then everybody's like in front of you. You are staying in a line, and then you are number 100. Tell you, find me the person in who is number 20. Okay. So what do? You know that the people are lined up in an order. So person after is number 2, the person after him is number 3, and so on. So now you can estimate where the number 20 might be, right? You know he cannot be at the end of the line because there's 100 people. Okay, and you know he cannot be like in the middle, and you know he cannot be after the middle. So you can estimate that number 20 should be somewhere just before the middle, right? So you will not count people, but you will jump to the middle.
Yeah.
So that is how the index works actually.
It comes in the middle.
Yeah, it will just, it knows that there's 100 people, and it knows that it's starting from number 1, and it knows that it goes like after you will be number 2, after that will be number 3, all the way down 100. So whenever you say, find me the person, for example, who is 33, now it can estimate that, okay, 33 is not at the end, 33 is not in the middle, 33 is like somewhere before the middle. Jump right to the 33. It's very like quick. But now imagine there is no index, and all these people are mixed up. After you 50, after him could be number 22, and a person after is number 31, and so on, all mixed. And now if I tell you, find me the person who is number 33, what will you do?
It's all mixed.
Okay. Yeah, if it's all mixed and there is no order, that means there is no index. The actual table is physically not ordered.
Yeah.
So now you have no idea. The number 33 could be at the end, it could be in the middle, it could be in the beginning, it could be somewhere after the middle. So you have no idea because there is no specific order, right?
Yeah.
That's why you have to search, scan all the people in the line.
Yeah, which takes time.
That's why it takes time.
Yeah, got it. Yeah.
Yeah. Therefore, whenever you create an index, it actually reorganizes the people. Say now you have all these people mixed up, like number 1, after there's number 22, after that there's number 5, and after that there's 50, and then after that 100, and after that 90, and so on, right?
Yeah.
That is called a heap.
Mm-hmm.
There is no order.
Yeah.
So, therefore, it's always difficult to find specific person in that line because you have no idea who is where. It's all mixed up.
Yeah.
That's why you create an index. Yeah. And when you create the index comes and tells these people, okay, order by your numbers. People get organized. People will stand like number 1, and then after him, the number 2, number 3, 5, and they will stand in an ordered line. And when you search, now index knows, now the SQL Server knows, because the index already ordered the people by their numbers. Now SQL Server can easily estimate where each number is. Okay? Does that make sense?
Yeah.
Yeah. So, but the order by clause, it doesn't actually order the people by their numbers. It will only show you that it's ordered, but actually it doesn't. Like SQL Server cannot use the order by clause returns in the result. It can only use what the index can do.
Yeah.
So that is the difference. Good. Now let's move on. So this is what we saw. A unique constraint or a unique index cannot be created on an existing table if the table contains duplicate values in the key columns. Okay. So this is what we did. There was duplicate. We removed that duplicate, and then we created the index, right? And this also we saw by default, a primary key constraint creates a unique clustered index, whereas a unique constraint creates a unique non-clustered index. Okay, I think we saw this in the previous class. So basically, whenever you create a primary key, it automatically creates an index. Okay. Okay. Now let's talk a little bit about the real life scenarios where you can use the unique index or unique key constraint or the primary key and all that. Okay? So in real world, the businesses, any business, let's pick any business, like let's pick the store, right? That sells all different kinds of things, right? So now imagine you have a table that contains the information about your customers, and there's another table that contains the information about your products, and let's say there's another information that contains the information about your statements, like income statement, tax, and all that. And now, say our customer table will contain obviously the information about the customer name, their last name, their phone number, and their address, right? And also they will have the IDs, right? Imagine this is the customer table, and this is the IDs, and this is the address for the customer.
Yeah.
Now imagine you don't have this ID column, you only have this name, city, that's all, let's say. Okay. Let me actually select that only. It will be more understandable. Name and city. So now imagine you have only this information. Imagine now you have two people with the same name and with the same city.
Yeah.
That is possible, right? Like in one city, there could be two people with the same name, right? That is possible.
Yeah.
But then, how do you know which person is which customer? Now, let's say we have this Jim Carrey from New York. And imagine we have another Jim Carrey from New York again. And now imagine one of these Jim Carreys owe you $100. How do you know which one of them owes you $100? Okay, they have the same names, same city.
By ID?
Yeah, that is why we need the ID column, right?
Yeah.
So imagine if you don't have the ID column, you are screwed. You don't know which one owes you the money. Therefore, you apply or add the ID column. Okay?
Yeah.
Now, you see, now you say, let's say one Jim Carrey is 5,000, one Jim Carrey is 5,001. Okay, imagine. Now you can easily know which one of them owes you because they have different IDs, right?
Yeah.
Like you can easily know, okay, this Jim Carrey with the ID number 5,000 owes me $100, not the Jim Carrey that is the with 5,001. Okay. Okay. Now, imagine if you do not have a primary key ID column. That means basically your ID column can also be duplicated, right?
Yeah.
Then it doesn't help you. Now imagine by mistake somebody inserted the same Jim Carrey with the same ID and same city. Now you're totally screwed.
Yeah.
Right? That's why when you create this table, you have to apply that primary key on this ID column so that no one ever can screw you. Okay? There will never be a duplicate value. Okay? In these cases, you use the primary key if you are only trying to match by the ID. So you'll apply the primary key on the ID column so that you will always know who is who by their IDs.
Yeah.
Okay? And now imagine, let's say it's an insurance company, right?
Yeah.
Let's say one car insurance company, and they have like millions of members, and they have the member table with their IDs, which is a primary key column. So each member is a unique member. Even they might have the same city, same name, but they will always have a different ID column. And now imagine we have another table that's called claims table. Claims means whenever an accident happens, you raise a claim, right, to that insurance company so that they can cover your damage. So now you should also have a claims table, and that claims table will have the claim ID and then say claims description and so on and so on. Right?
Yeah.
And now you have another table that combines these two.
Yeah.
Let's say claims result or something. Let me actually open up this Excel so that it's easier to understand, okay? Just a second, give me 1 second. Okay. Okay, now this is insurance company, okay? So I'm trying to explain to you, like in real life scenarios where you can use this primary key, unique key constraints, and the indexes, okay? Let's say it's Geico. Okay? So now we have this Geico insurance company, and they have, say, members table. And the members table, let's say, will have this, say, name, members, name, ID, and city. Okay. And they also have, let's say, claims table. Okay. And these claims will have, let's say, also, I'll just type this 1, 2, 3, 2, 4, 1, 2, 5, 1, 2, 6. Okay. 2, 7, 2, 8. Okay. And then this will be the say description. This is claim ID. And this is description. Description will say the hit from front, let's say total damage or something like this, okay? And so on, etc., etc., etc. Okay? So now we have these two tables, all right? And actually, this claims this is the type of the claims. This is the members. Okay. And now let's say we have the actual say active claims. This is another table. So basically, these are the types of the claims that we can have. These are the members we have, right?
Yeah.
And each of them have a primary key on this column. So you can only have unique members by ID. And you can have only this unique claim types, okay? You cannot have more than this kind of claims. You cannot have more than this members, okay?
Yeah.
And now we have, say, active claims. That will have member ID. That will have claim ID. And that will have claim description. Okay? Now, this is where the business comes in, okay? Now, imagine a situation. Can one member have multiple claims? Yes. So I can, like, say, hit my car, somebody can hit my car, or I can have my tire blown up, or I can have my car totaled. I can have multiple claims at the same time, right? So that means, let's say this person who is Jim Carrey, whose ID is 5,000, okay, can have a claim that says 123, which is hit from front, okay? And let's say the same person again, Jim Carrey, will have another claim that's this, and that's this, okay? And this would be this, and this would be this, okay? This James Blunt, who is 5004, will have two claims. Let's say he has these two claims also, okay? So basically now by looking at this table, I can say, okay, member number 5000 has three problems and we have to pay for these three things, right?
Yeah.
Three different things. And member number 4004 has these two claims and we have to pay for these two things. And now if I ask you one question, can this be true? This last line.
Oh, nice. Oh, we got etc. for 5,000. And yeah. It's repeated, is the same?
Yeah. So basically, now what this table is saying is, okay, let's say these are active claims. These are the ones that we need to pay for, right?
Yeah.
For this total damage, we have to pay 5. So basically, one person, James Blunt, Jim Carrey, he has a claim ID 124, which is a total damage, and for that we have to pay 500. And then the same person, same thing, total damage again, and we have to pay him another 500. Right? This in this case, we're basically losing $500 because this is the same thing.
Yeah.
And basically, we are paying for the same thing 2 times.
2 times, yeah.
Which is incorrect, right? Which is it will just break your company. Like your company will go bankrupt in 2 months if you keep paying for your members more than what they should receive, right?
Yeah, yeah.
Okay, so and now imagine there's like millions of members, and there is no way to track each of them. You might have, say, this type of things like in hundreds of thousands of places.
Yeah.
That means like each time you're losing $500, $100, $200, whatever, it adds up, and your company will lose big amount of money. How do we avoid this? To avoid this, when I create this table, I can say, okay, create unique key constraint on these 2 columns. Right?
Yeah.
If I create a unique constraint on these 2 columns, now I will never have the same thing twice.
Yeah.
Okay? Does this make sense? Now, if let's say I have this 5,124 already, right?
Yeah.
If someone else by mistake tries to insert the same thing, right? It will throw an error. It will say, okay, this data already exists.
Yeah.
Okay, so this saves your company a lot of money. Okay, so this is the real life like scenario for key constraint, the primary key constraint. Okay.
Yeah.
Does this make sense?
Yeah. Yeah.
So this like primary key, unique key, all of those constraints are actually used to force business logic to your databases and to your data and tables.
Yeah.
Okay, these are very useful, but the only thing you have to use them based on the business requirements. Okay.
Yeah.
You cannot also overuse them or use them incorrect. Let's say if you don't understand the business and if you don't know that one person cannot have more than, can have more than one type of claims, right? And you say, okay, I will insert unique key or primary key on this member ID column. Okay, that would make it like you can only insert one member here only, so you cannot insert these 2 claims, right? Your customer would sue you. They would say, okay, I have 3 problems, but you only are showing me 1 problem. Since you have primary key on this member ID column, that wouldn't let you insert more than 1 distinct value here. So you'd have only one of these 5,000s and one of these 5,004s. And you're basically losing these 2 rows, these 3 rows, and this also. That way, you actually end up not paying your customer, right?
Yeah.
These 2 amounts. Where the customer will basically sue you.
Yeah.
Okay? So what I'm saying is this primary key, unique key, all of these constraints, you have to first understand your business before using them. You have to understand, okay, can one customer actually have more than 1 claim? If yes, okay, we'll use that across these 2 columns. Okay. If not, then we'll just use across 1.
Yeah.
And here, can this members table, the information about the members, have more than 1 member ID the same? No.
Yeah.
If it was true, like if you had 5,000 twice, then it wouldn't make sense. You would mix up all these members. You wouldn't be able to distinctly select your members.
Yeah.
In this case, you have to use the primary key only on this column. So what I'm trying to tell you is you have to first understand the business requirement before using this constraints or indexes. Okay? So basically now what an index does is, index does the same thing. It uniquely identifies it if it's like a unique index, like unique clustered index or unique non-clustered index. Plus, it will also speed up the process.
Yeah.
Okay, so index does the same thing as the constraints do, but in addition to that, it will also speed up the scanning process. So whenever you select some data from the table, it will be fast.
Yeah.
Okay.
It organizes the data. Yeah.
If it's clustered index, it will actually organize the data. Then the logic behind how it finds this, I just explained to you about those 100 people in a line, right?
Yeah.
It works just like that. It knows where each person is, and it will just jump right there where that person might be if it's in an organized order. Okay?
Yeah.
Okay, good. Does this make sense? Okay, nice. Let's move on. I guess we have some more time. I'll try to cover one more topic. Okay. So this will be just the advantages and disadvantages of indexes. We might have covered this already, but we will talk a little more in detail. Okay. So the first thing that I told you the previous lesson is, of course, there is an advantage of using an index, which is obviously it will speed up the process, like it will make it fast to retrieve the data from table. There's a disadvantage when, especially you're trying to, now you have the cluster index and you are trying to insert data into that table. It has to first find the correct place, spot for that new row, and then insert it. Okay.
Yeah.
Basically, instead of inserting the data as it is, like as it's coming, you just, if it was a heap table, you would just insert it from the last place and you would just move on. So it would be just fast. But if you have the index, now you have to first scan the table and then find the correct spot for that new row and then insert. So this makes it inserting or updating or deleting process slower.
Yeah.
That is one of the disadvantages of using indexes. And to overcome that, the best is first drop the index. Basically, you make the table a heap back again. Once it becomes a heap again, you insert the data, and then you recreate the index. Okay, that way it's faster. Let's look into some more advantages and disadvantages of the indexes, and the types of queries that can benefit from indexes and covering queries. Okay. So the first thing is advantages of indexes. It's obvious. So we have learned that the indexes are used by queries to find data quickly.
Yeah.
So I have, I think, explained this multiple times, how the indexes help to find the data quickly. Just like the cluster index orders the data, non-clustered index actually does the same thing, but it basically takes that copy of that column and creates the pointers. So it copies that column and orders that column in a copy, just like the index page of the book. That's why you perform one more step, but it's still fast. Okay, so the advantage is it helps the queries to find the data quickly. Okay. Next thing is a disadvantage of indexes. First thing is the additional disk space. As I was just saying, it's especially true for the non-clustered indexes, because clustered index doesn't actually require any additional storage because it reorders the actual data, right? It doesn't copy the data anywhere.
Yeah.
It just reorders the data as it is. So it doesn't require any additional disk space. But every non-clustered index requires additional space. See? Because as it stores the that part of the table separately. Okay.
Yeah.
The non-clustered index, it is actually stored separately from the table.
Yeah.
Just like if we go back to the same example of textbook. In the textbook, you have one or two additional pages at the end, right?
Yeah.
That contains only the pointers. That will only have the chapter name and the page.
Yeah.
Okay, page number. That helps us to find the data quickly, but at the same time, we are using 3 more pages.
Yeah.
Right?
Mm-hmm.
So just like that, non-clustered indexes also are stored separately from the table, and therefore they have to store those pointers in somewhere. That requires an extra space.
Mm-hmm.
And the amount of space required will depend on the size of the table and the number and types of the columns used in the index, okay? It depends, like if it's like million row, so you'll basically have, if you create non-cluster index on one column, you'll basically have one extra column with million rows.
Yeah.
So that is the amount of space you will need, extra amount of space. And then the second disadvantage is, the one that I just told you, is the insert, update, and delete statements can become slow.
Yeah.
Okay? Because like when the DML, it means data manipulation language, it's not a separate language, it's just another way of calling the insert, update, delete statements, okay?
Yeah.
DML is not a separate language. It's just a part of SQL, or even better to say, these 3 SQL statements, insert, update, delete,
Yeah.
they are grouped and called DML, which is data manipulation language. It manipulates the data. So anyway, when this insert, update, delete statements modifies the data in a table, the data in all the indexes also need to be updated, right? Because now imagine we have this table, and we have this clustered index, right?
Yeah.
And that means it has to be always in an order.
Yeah.
So now if I try to insert a row that's 5014,
Mm-hmm.
it should come after 13 and before 15, right?
Yeah.
So when I'm doing the insert, it will scan all these rows, or actually, since there's an index, it will still have to find the right spot and then insert. If I didn't have the index, it wouldn't be worrying about finding the right spot. It would just insert it right at the end. Okay, that's why it can become a little slower when we're doing the insert or update delete statements on a clustered index.
Mm-hmm.
Okay, even there's non-clustered index that also needs to be updated, right? Like for example, now we have a pointer which is in a separate place, and now we have inserted 1 or 2 rows. Now those rows also have to reflect in that pointer, right? Like say you have a textbook, you added 2 more chapters to that textbook. At the same time, you have to add those 2 information about those 2 chapters in the index pages also, right? So instead of doing only adding the pages, you also adding those pages in those index pages. So that makes it slower. Okay. So indexes can help to search and locate the rows that we want to delete. But too many indexes to update can actually hurt the performance of data modifications. Okay, so it like finding the correct place for these new rows or the rows to be deleted is not that of a big deal. The problem is to update those indexes after.
Yeah.
If you don't update those indexes, well, basically you don't update them manually, but SQL Server, if it doesn't update those, say, indexes, now imagine you have two new rows, but those two new rows are not in the index. And now let's imagine you are searching for those two rows, and then SQL Server goes to the index and looks for the two rows and cannot find those two rows in the index.
Yeah.
That creates a problem, right?
Yeah.
Therefore, whenever you do an insert, SQL Server has to update the index also at the same time.
Yeah, sure.
Otherwise, there is no use of the indexes if it doesn't contain the latest data. Okay. And there's another thing called a covering query.
Yeah.
And what is a covering query? So say, let's imagine if all the columns that you have requested in the select clause of query are present in the index, then there is no need to look up in the table again, right?
Yeah.
The requested columns data can simply be returned from the index itself. Like imagine you have clustered index.
Yeah.
The clustered index is what is the clustered index? It's the actual column itself, right? Like if we looked at that B tree, when you reach that leaf level, you are on the actual data, right? Because it actually reorganizes the physical data.
Yeah.
So that's why it's called a covering index, because now when you search for something, say your index has the actual data, and you search for something, find that something, okay? Now it doesn't have to go back to the actual table. You can actually return the result from the index itself, because the index itself contains the same data, right?
Yeah.
But for example, in this case, let's say we have a clustered index on this ID column, right? Okay. And if I want to select, let's say, and this is like 1,000,000 rows, let's imagine. And I want to select only the ID, where ID equals to 5,003, right? Now imagine this was 1,000,000 rows, okay? And since we have a clustered index on this ID column, that means this ID column is actually the part of the index. So now when I do execute this select statement, when I execute this, it will return me 5,003, and how it's doing it is, when it goes to the index and looks up for this column, and it has to return the same column that is in the index, it doesn't have to go back to the table. It can return the actual ID from the index itself, right?
Yeah.
That's called covering index.
Yeah.
Yeah, like imagine now we have this all these columns and all these rows, right? Imagine we have non-clustered index on these two columns, or say 3 columns, okay? So now these 3 columns also get copied to that non-clustered index, right?
Yeah.
Since non-clustered index is it's in a separate place, but in the actual table it's actually stored in a separate place. And when I, let's say, if I search for the ID and the name, okay, from this table where ID equals to this, okay? And when I do that, it returns me this result, but how it's is, basically what it's doing is, it's when doing the select statement, it's coming and searching this ID in the index itself, in the clustered index, right? since the cluster index includes these 3 columns. Okay? And when it finds this ID 5003 in the cluster index itself, it can return the data from the index itself. It doesn't have to go back to the table and take the data from the table. Since it's the copy of that table, it can return this data from the index itself, right?
Yeah.
It doesn't have to go back to the table.
Yeah.
That is what's called covering index.
Covering, yeah.
See, and it says cluster index always covers a query because it's logical that because the cluster index it doesn't actually copy the data, it's actually the column itself. It just organizes the column itself, right?
Yeah.
So since it contains all of the data in a table, yeah. Okay.
Okay.
Composite index is an index for 2 or more columns. Yeah. That we also, I think, saw in the previous lessons. When you have like 2 or more columns in one index, that's called a composite index. So both clustered and non-clustered index can be composite indexes. To a certain extent, a composite index can cover a query. What does that mean? We have this composite index that is to 3 columns: ID, name, city, right? So when I am searching for ID, name, even say city also, this composite index can still cover this query, right?
Yeah.
I will show you that in even in a better way. Okay. Now imagine this is the composite index only. Okay. Copy this to Excel. So composite index, and this composite index is on these 3 columns. Okay.
Yeah.
That means this composite index actually will copy the data from these 3 columns in a separate table, which is a composite index table. Okay. Now I also have this table, right? This is the actual table now. Okay. The whole table. Okay. This is the whole table. So what I'm trying to do is I'm trying to explain how the covering index works, okay? And at the same time how the composite index works. So now imagine we have this actual table, and then we have created this composite index on these 3 columns of this table, right? We have this copy in the index. Now if I search for, if I say select ID name from this table where ID equals to this, okay? It comes here, finds this in the index, okay? Yeah. And then this same columns that I want in my select statement, which is the ID and name, or also in the index itself, it can return the data from the index itself, okay? It doesn't have to go back to the table. Okay? This is what's called covering index, because this index itself will cover for that SQL statement. Yeah. Now imagine it can still cover if I'm selecting ID, name, and also the city column, because that also exists in the index itself. And let's say we're looking for these 3 columns where the ID is 5005. It finds that in the index, it doesn't have to go back to the table. It already has all the data in the index itself. So it will return that also. And now imagine I want to select all of these columns. Okay. I want the ID, name, city, and commission for, say, 5004. Now it cannot cover. because it will have ID, it will find the ID, it will find the name and city, but for the commission, it still has to go back to the table, right?
Yeah.
So this means this cannot cover it. So now still it has to go back to the table and select all of them from the table and then return this.
Yeah.
Okay? Does it make sense?
Yeah.
Therefore, when it says the composite index, two more columns, both cluster and non-cluster index can be composite. To a certain extent, a composite index can cover a query.
Yeah.
Okay? It can cover to it can cover to a certain extent. As long as those columns also exist in the index, it will cover. Yeah, but if any of those columns don't exist in the index, then it cannot cover for the SQL select statement, because if you're asking for 4 columns in your select statement, the composite index has only 3 columns, then it has to return that also the 4th column also, right? Now it cannot cover, so now it has to go back to the table and retrieve the data from the actual table. So as long as in your select statement you have the same columns as you have in your index, it will cover for that select statement. It will not go back to the table. It will retrieve the data from the index itself. But once you have more than what you have in your index, it has to go back to the table and then return it from the table. First, it will search in the index. Once it has the pointer, it will go back to the table and find that whole row based on that pointer from the table and return the data from actual table. But if you have all those columns in the index itself, now you will find the pointer also, and then it will not go back to table. It will just return all those rows from the index itself. It will be even faster. Okay, but then there's another problem. Okay, if composite index it can cover for all the queries, okay, that's fine. Why don't we just add indexes to all columns, right?
Yeah.
If you have all of the columns in the index, it will never go back to the table. But then what is the difference now then? Like, you have the same table as an index now. It will, instead of searching the table, it will be searching the index. Now there's no difference.
Yeah.
Okay? So you have to have the indexes only on the necessary columns, like the columns that you think will be mostly used in your filters. Does it make sense?
Yeah.
Okay, good. I guess that's it for today. Looks like we covered 2 more classes, and I'll send you the slides, but I don't think I have any scripts for today. It was only the examples. Okay.
Yeah.
Um,
So that's all.